Macrolang is a cool way that we can use a robot, RHOBOT, in chat to program on RChain and other things in the future. It uses a macro processor from the late 60s, the C preprocessor, which has its foibles, and it serves our purpose reasonably well. So we have, we can define names like print, and the print is defined, and we can show how it's defined with the show command. It shows a built-in command that shows you how macro is defined. And we can see that print is the print macro takes one argument, row. We call row. Call it anything we want. And it's defined to create a new unforgeable name. And then we have a macro, $. All our macros start with $. And that helps, that avoids most of the unpredictable behavior that might be introduced by CPP. By using $signs, CPP is a lot safer. And we can find our, we distinguish macro names from names in RChain. But here we are creating names. And it creates the name standard out in this particular macro. As we'll see below. And then we have some RChain. And the RChain writes the standard out. Okay, the exclamation point means it writes the standard out. And what does it write? It writes, it comes in parentheses after the exclamation point. It writes out the value of row, which is the RChain we passed to the print macro. Okay, and we can echo print and give it an argument. In this case, and give it 1 + 1, which is a RChain expression. And with the echo, we see what would be generated. Okay, and we can see that it does a new standard out, which is an unforgeable name it associates with the standard out device, the row IO. And that means, so the unforgeable names that gets associated with standard out, it becomes associated with the output device. And we have this new standard out in this RChain, which outputs the standard out, the value of 1 + 1. So that is the argument that we gave in the echo. Okay, now if we want to run this RChain, okay, we use the eval built-in command. and robot comes back and gives us the answer to stand, shows us what goes to standard out, and in that case it's 2, and then we have some cost accounting as to what would cost in this event. And then we print, we have another convenience, syntactic sugar, so that we can call the print macro as a command, print colon, and pass the arguments without parentheses, separated by commas. In this case, it's just one argument, row, for print. This is how it's defined. Probably should define colon in front of this, just so you know the command that defines it, which is a built-in define command. Just put in the signature of the macro, which is the value name, and then the dot with args. These are arbitrary names that we can give them. And they simply get replaced with the text that we put in there. It's just textual substitution. That's what the macro processor does. Okay, so we can do print and then give it some row line, row plus world, and we can see the standard out we get row world. Plus plus is concatenating, string concatenation of structures, strings, lists, maps. I haven't tried with maps. I think this would work. Okay, and then here I pass it. I pass to print the process 1 in parallel with the process 2. So they both run at the same time. And then I print the evaluation of that. And I get back a 2. Well, I could have just as well got a 1. They're both, neither one of them could, which one of them goes to standard out is indeterminate in row line. Now I did it a few times and I always get back a 2. It never gave me 1. And then we'll move on to a more complicated example. We have a utility function for macro for each. And if we show the definition of that, you know, this is a transparent environment. We can see what we're doing. We can look at the code and hopefully determine, is this a safe thing to do? Is this what we want to do? Is this correct? No. So we see that the macro is defined to take 2 arguments, a collection and code. And the code, the object is to execute the code for each item in the collection. And It's a utility function, so we handle different kinds. We handle different kinds of collections. We handle maps, key value, list key values. We handle maps, lists, which just a list of values, and sets, which are like lists. So if you pass a list, a set, a list, or a map as a collection, this will work. It doesn't handle tuples, which are just values separated by commas and parentheses. Not quite sure how to do that. We could also handle processes in parallel. We could have that can be considered a collection, but they're not supported yet by this function. Maybe better to have different functions for the different types, because this isn't the most efficient to combine them, way it is that combine them. So we create a new, we create standard out so we can do output. Now, I don't know if we do any output, but it allows people to use standard out in their code without having to define. So it's convenience function. And it makes a name underscore loop. And when we make names in these functions that include people's code, we don't want to use names that conflict with names used in their code. So the convention I'm using here is to declare the variables with an underscore in front, so that a user of a macro can expect that they may use names that start with underscore. If they're code, if they pass code to this. So the way this works, and we'll just follow one case. We have we could have an empty map, in which case it's all done. It doesn't have anything to do, it returns a no. Now I could have a map that contains a key and a value, and other entries, which we call the tail. That's the rest of the keys and values. But we're binding the name underscore key to one of the keys, and its corresponding value is bound to underscore value. So we can use those we can use underscore key and underscore value in our code to reference the values. So it handles the key and the value, and then it loops. It sends loop the rest of the values that it hasn't done yet to the loop, and this is this is the contract loop. Okay, and so it'll do one item from the list. It'll call loop and work on another one that's left over. And it'll keep doing that until the list is empty and returns no. And the map and the set work the same way. Okay, and in parallel with this definition of a contract underscore loop, we're calling loop with the collection that's passed to the macro. So we're sending this collection to the loop. And it peels off one key and value at a time, or one value. Here where we call for each, and we pass the collection and code. So the collection we passed is a list, 1, 2, 3. And the reason I have the parentheses around it is because if you have commas that are not in parentheses, the macro processor will treat those as separate arguments. And so it would, so this would be the collection, and 2 would be the code. Well, actually it wouldn't work because it had too many arguments. But so for lists or maps, we have to use parentheses. Sets already have parentheses. In many cases, we don't have any commas, or they're already in parentheses. But we do have to use parentheses when there aren't any, and we use commas in macro call. So for each of these things, we're going to send a standard out the value. Okay, so this is a list of 1, 2, 3, and we can see we got the standard out. We got a 1, 2, and a 3, and the cost. All right, you didn't get it all. Attend a work study in the code lab, and we'll answer all your questions. An example usage is if we look at the chat. We can see the chat is defined to take a user and a message. And then you call send macro to send the user a chat, username, we sent it, and the message. Which can, we can send, we use send to send capabilities to one another as well as messages. And I could do a receive chat to standard out. I'm going to print it log. I'm going to use something else. Oh, did I do that right? I spelled standard out wrong. And hopefully I have something waiting. Yes, I sent myself the chat earlier. So from Jim's driver, I got the message, hi myself. This is cooperative development, so we don't want to step on each other's feet. So we try to work out loud in the testing bots channel. And that way we can help each other on mistakes or whatever also. Although testing bot channel can have a lot of stuff in it. Sometimes it's interesting to follow somebody's development process there. If we're just exploring and we're not really changing anything, just doing shows in the valves and running stuff ourselves, but aren't going to define globally macros that are going to affect everybody else, or change macros that are going to affect other people. We can go to directly to direct message with robot, who and you know that you can. Oops, you can click on a robot, send a message to him privately, go over things. And then if you want to find out your problem, you have to zoom or a big blue button with someone else to look over your private chat, see what you did wrong. All right. If you want to run this on your own server, oops, you or your own machine, okay, you can test robot from the command line. You're running if you have RNode installed in your machine. Or you can create your own bot, and instructions are down in here on how to create your own bot and set it up in your own server. And you can customize it your own way. Simply fork the code from Jim Scarver, github.com/Jim Scarver/row-bot. The contributors, I don't think they're all listed here. Dan helped refactor the code for object capabilities. The code is still pretty young. There's probably variables that could get stepped on if you have too many people running, and it actually can mix up standard outs when people are running things at the same time. But it's pretty good. Also, Adi and Gary, Steve, and others have helped on this. I'm Jim Scarver anywhere. Let me know if you need help using robot, and we'll see that you get it. Thank you. Have a great day.